Hi, my name is Thomas Bonepton. I'm a PhD student at Porlo Lab, and I'm going to present you my project, Haptic3D, which is the design of a 3 degrees of freedom pediatric haptic robot for upper limb rehabilitation. The motivations behind this project comes from the limits of traditional rehabilitation. First, there's a lack of standardization in the movements that are performed, and also we don't have any precise requirements of the performances of the patient and the progress of the treatment. Also, it imposes a burden on the personnel. That's where a rehabilitation robot has emerged as a very good solution. However, they have their own limits. First, they're very not accessible and very expensive, and they're not designed for pediatric patients. So the objective of this project is to design a 3 degrees of freedom and effector rehabilitation robot specifically designed for the pediatric population with the following requirements that we've established with clinical experts. First, the robot needs to be portable and lightweight so we can move around in different space in the hospital, but also that it could be brought home. We also want it to be customizable for amplitude and speed of movement since the pediatric population has very different needs. The robot needs to be cost effective and accessible. This project has two parts. The first one is the design of the robot, and the second part is the design of an adaptive control system. Let me present you the prototype. First, the structure is made of aluminum extrusion. We have a larger base that is fixed and a smaller base that can rotate. On the figure here, you can see the red arrows. Those are the 3 degrees of freedom of the robot. So, as I said, we have the smaller base that can rotate, but we also have a central platform that can go up and down thanks to the Macron linear actuator and technic motor. On that little platform, we have an Orca Smart motor that can, which is a magnetic shaft that can do movement in the X direction at high speed, high forces, but also be very precise and produce very advanced haptic feedback. All the power sources, cable, motors are all at the back of the robot for safety reason. For the second part of the project, the adaptive control system, the idea would be to have a solution tailored to the needs of every patient so that the control system can adapt during a therapy session but also during the whole treatment. The possible outcomes and impacts of this project is be the first rehabilitation robot that is specifically designed for pediatric patients. Thanks to our future control system, but also the Orca Smart motor, we can produce very advanced haptic feedback. Also, the current prototype is very portable and cost effective, so in the future we can use it for telerehabilitation. Thank you for listening to my presentation. If you have any question concerning my project, don't hesitate to reach out. Thank you.